For our last model, we're going to look at what happens when interest rates change. Right, it's common for many types of loans to actually get interest rate changes that happen over time. There are adjustable rate mortgages where it actually floats every year. And in particular, in student loans, many lenders offer the option of giving you a discounted interest rate after you've made a number of consecutive on-time payments. For example, after 3 years of all on-time payments, maybe your interest rate goes down by, say, 25 basis points. Right? These are incentive programs for lenders use to get borrowers to kind of get in the habit of paying their loans off over time. So whatever the reason, we want to be able to build this flexibility into our models. So the way we're going to do this is we're going to think about, in this case, we're going to have an initial rate period, 3 years. And after those 3 years, we assume you make your payments on time. You then get a 25 basis point reduction. So what we're going to have to think about is that the payment is going to change when the interest rate changes. So the first thing we're going to need to do is get the interest rate for each month into the model. So we have this new column here, and this is a simple one. We're just going to say if the month is less than or equal to our interest rate years times 12, well, then we just want the annual interest rate of 4%. Otherwise, we're going to want the 4% minus our interest rate reduction of 25 basis points. All right, so that's a simple way to do it. Another way to do it would be, using index match or VLOOKUP if you had an interest rate table, right? You can think about that with an adjustable rate mortgage or any number of other ways, whatever way it works to get, for your particular problem, the interest rates into the model. So we can see here that we have our interest rate change from month 36 down to month 37, all right? The next thing we're going to need to know is how many months are left each period. All right? The easy way to do this is recognize that we have 240 months. We could subtract out the month we're in. So we could do this calculation dynamically kind of in our formula we're going to write, but I'd prefer for it to just be explicit so we can all see it. So the way we're going to do this is multiply our years times 12, and we're going to add 1 to account for the fact that we start in month 1, and then subtract off the month we're in. So in that first month, we have 240 months remaining. If we drag that down, we see it goes down, down, down until we get down to our loan paying off in month 240. Now the last thing, and this is kind of the big trick in these models, is we're going to have to calculate the required payment. So what we've done in the past is we calculated this one static required payment. It's that $1,211 every period. But when the interest rate changes, the payment has to change as well to make sure we still pay off that loan in 240 months. So that means we're going to have to do a dynamic payment calculation. And the way we can do that is we can use the rate prevailing in the month, the number of periods remaining, this is why we calculated that, and then the present value of the loan at that time. Now, typically we've just used $200,000, the starting balance, but what we can use is the beginning balance every period, right? Whatever that beginning balance is, you can calculate how much you have to pay over the remaining term to pay it off in time. So this is the sense in that it's dynamic, is that we're going to update it, and as we drag down, it's going to update based on the new beginning principal amount. So let's drag that down. Let's see what changes. So down here, we see the change happening again from month 36 to 37. We get that about $22 drop in payment because we saved 25 basis points a month. All right, so we've calculated our payment. Now we just need to build it into our model to make sure everything's working. So here, let's go over to payment. And instead of basing this on C9, which is where the static required payment is, let's go ahead and put in our new required payment that we've calculated for each month. If we drag that down, let's go see what happens. So we're at month 240 is what we're looking for. And let's see, we didn't quite pay off the loan. All right, there's 26 cents left at the end. It's not exactly clear why we didn't pay off the loan, but you want to start thinking about where could things have gone wrong. All right, so it didn't equal 0, so we need to figure out what happened. Well, it turns out what happened is that you need to account for the interest rate change in this interest charge as well, right? We're using our static interest rate before. Now we need to pull that over here and make this so it's actually a dynamic interest rate, right? And actually in this model, notice that I no longer have my nice wrapping around this to make things disappear. That's an extra feature you could add at the end to make the model a little bit nicer and dynamic. But here what I'm going to do is just change this, right? We change it to F7. We don't want to lock it anymore though, because we want it to move dynamically. So now if we copy that down and we go back to the bottom, now we see that we ended up with exactly a zero balance. We have our right payment as well, and it's all working out and paying off at the end. So now what kind of question can you ask? Well, notice we already have our NPV built in from the prior model. And so we can see that by getting this 25 basis point reduction in your loan value, in the loan interest rate, the NPV of the loan goes to $2,988. Almost $3,000 is the savings from that 25 basis point reduction. How can we make sure that our model's working? Well, let's just set our reduction to 0. The NPV is 0, right? Because if we're not getting a reduction, the interest rate is equal to the discount rate, and everything gives us an NPV of 0. If we put our 25 basis points back, there's our $3,000 value. Even if we saved 1/8 of a point, that's going to give us $1,500 of savings. 50 basis points, that's going to save us $5,000. Say instead you could refi after 3 years and save 1%. Now that's worth $11,000 for us. So you can start to see the value of these things. Again, with different ways of modeling the problem, we build in richness in our financial modeling, but we also get to analyze kind of more interesting personal finance and get an idea of how valuable different consumer financial markets and products are to us as consumers.